going to be doing something called finding the particular equation of a quadratic given limited information. So in one scenario, I'm going to give you 3 points, and we're going to find the particular equation of that quadratic, assuming that the 3 points are members of that quadratic. And then I'm going to give you another scenario where I give you 1 point and the vertex, and we'll find the equation of a different quadratic. Now, why would we want to do this? Well, maybe you're given 3 points and maybe they're arranged like this, and you're wondering, I wonder what quadratic, because quadratics produce parabolas, what quadratic function would contain those 3 points. And if you can find that function, then maybe you can find other points on that same function. But you can only find the other points if you know that function, the function itself, and you can plug in an x value, get the y value, and then you have another point. But for starters, we only know the 3 points, so we don't know the function yet. But 3 points is enough for us to find the function. So here we go. Let's say these 3 points are members of a quadratic function, or you want them to be part of a quadratic function, so you can find more points. Okay, so we know that any quadratic function in standard form looks like this, where x is the independent variable, y is the dependent variable, and a, b, and c are constants. So if these 3 points are members of this function, then that means these ordered pairs fit the function. So I can put any one of these ordered pairs into the function, and the function will work for those 3 points. And so I'm going to do that one at a time. I'll do it first for this ordered pair, then this ordered pair, and this ordered pair. And so when I put all the ordered pairs in there, I get that from the first point. And then when I put the second point in, I get that. And then when I put the third point in, I get that. Now it looks ugly at the moment, but notice I have 3 equations with 3 unknowns now. So that is solvable, because then my number of unknowns equals the number of equations. So I'm going to do this by linear combination, also known as elimination. I'm going to take the first 2 equations first, and I'm going to subtract them, since I know the c's will disappear when I do that. I'm just copying them down right here. Okay, so I start subtracting. And I get that. Now I have an equation with 2 variables, still unsolvable. So I need a second equation, which I will get by subtracting these two equations. And again, just copying them down here. Okay, so I'm going to take these two equations and stack them to get ready to do linear combination again. But this equation, I'm going to multiply it by 3 because I want the coefficient of this term to match this one. So when I multiply by 3, I get this. And when I subtract, the b's are going to disappear. Let's see, this will give me 48a. So a equals 1/2. Okay, the hard part is done. I know a is 1/2, and now I can put 1/2 in here for a. Okay, the 1/2 has been put in, so now I can solve for b. B is 3, almost done here. Now I can put a and b. I'm going to pick this equation here. I'll do it over here. 4 times 1/2 is 2, minus 2b, and b is 3, so 2 times 3 is 6, plus c. And c is -7. Okay, so now I know that my ordered triple for a, b, and c is 1/2, 3, and 7, but remember what I was trying to do. I was looking for the quadratic function. So the actual answer, final answer, is y equals 1/2 x squared plus 3x minus 7. So this is the quadratic function that contains these 3 points, -11, 413, and 629. And if I wanted to know another point that is a member of this same function, I just have to pick any x value I want, and I'll get the y value, and I'll do that right now. So let's say I want to know what the x value of 6 would give me. So if I put 6 in here, that's going to be 1/2 times 36 plus 18 minus 7, and that'll be 18 plus 18 is 36 minus 7, which is 20. Oh, I already knew that one. Sorry. Let's go with 8. Okay, if I put 8 in here, I get 32 plus 24 minus 7, and that's 56 minus 7, that's 49. So 8, 49 is another point on this parabola, and it kind of makes sense. Just show you a rough graph of all 4 points here. So -2, -11, we'll just say it's right there. And then 413, we'll say it right there. 629, way up there. And then 849, way up there. So you can see that, yeah, there's a part of a parabola that I can already see here. Okay, now on to the second type of problem where you're given different information. So what if you're given that the vertex is 2, -5, and then you're given another point 3, 1, and that's all. That's all that you have. Okay, no problem, because we have something called vertex form. And this was mentioned in a previous video. So vertex form of a quadratic looks like this. HK is the vertex. A is a constant, and x and y are the independent and dependent variables as usual. So since I'm given the vertex, I can, and this is h, and this is k. Since I'm given the vertex, I can put the h value here, I can put the k value here, and I can put this ordered pair 3, 1 into x and y. And if you can envision me doing that, I can then solve for a. And notice in the vertex form, all you have to do is solve for a. It's the only constant you need to solve for, as opposed to earlier in the standard form when you had to solve for a, b, and c. So that's good news. Less work. Okay, so I'll put everything in. 1 equals a, which I don't know yet, x minus 2 squared plus k, which is -5. And first I'll add 5 to both sides. Oh, I forgot to put in x. I'll do that now. So a is 6. So I know that this function is y equals 6, x minus 2 squared minus 5. Now this is vertex form, remember? And most of the time when they ask for a quadratic equation, they're going to want it in standard form. So I can't leave it like this. If the directions say leave it, if the directions don't care which form, then you might as well leave it in vertex, but I'll put it in standard form. So I just have to FOIL this out. And there we go. Y equals 6x squared plus 24x minus 19. Okay, so just to summarize, we found the particular equation of a quadratic given 3 points by setting up the 3 by 3 system. And we found the particular equation of a quadratic given a point and the vertex by using vertex form. Okay, see you next time.